Excellent. Thank you. Thank you very much, Stephen and Kevin, for the introduction. I'm really excited actually about this two-day event. So thank you for giving me the opportunity to speak with you today. So I'm going to start sharing my screen. And please let me know if you can see my screen now. In presentation mode.
Perfect. There you go. Yep.
Awesome. Okay. So Kevin mentioned a few challenges that I'm going to build upon some of the challenges that he mentioned. The challenges for data scientists in mining, as I experienced as a data scientist. Quick background about myself. I'm currently Director of Advanced Analytics at Equinox Gold, based out of Vancouver. I have 12 plus years of experience in the data science field in multiple industries and academia, in heavy equipment, mining, obviously most recently technology as well as academia. I worked and studied back home from my home country, Iran, lived in South Korea, UK, and Canada. Fun fact about me, I'm pretty tall. 6'6", 2 meters tall. I used to play basketball a lot. So you can imagine during COVID, my friends used to make fun of me if, you could use me as a measure for social distancing. So that's how tall I am. Undergrad in electrical and electronic engineering. A lot of exciting experience with control systems and power systems, followed by a PhD in computer science, specifically in image processing, and also followed by a postdoctoral fellowship at UBC, specifically in the field of visual analytics and data science. I love playing basketball, as I mentioned, kayaking and nature. But these days, honestly, these kind of becoming my dream because don't find enough time to do all that. All right, so with that, let's also give you quick, very high-level information about the company I work for, Equinox Gold. We are one of the fastest growing gold companies on earth. We've had a pretty aggressive growth trajectory in the last 3 years, currently operating 7 gold mines across the Americas continent, Canada, US, Brazil, and Mexico, the 4 countries that we have operations, and also actively building 5 mines in all these 4 countries, producing over 600,000 ounces of gold, and well in our way for 1 million ounces per year, that the target that we have. More information, please go to our website. Lots of cool information there. Nice pictures as well, if you want to follow. All right, next one is some of the challenges that I'm going to be touching on today's short talk. This is how I sort of pictured the data science challenges in the mining space in 3 main, I would call them themes. And number 1, finding. 2, moving, and 3, extracting. And you can see the traces of data science in all of these 3 themes of mining. Finding, obviously, you're looking for mineral deposits. It's a pretty complex, challenging process that involves different techniques, mathematical techniques, and data collection techniques. A couple of the prominent ones, target generation, geochemical anomalies, and prospective areas. Again, you're finding needle in the haystack, and remote sensing technologies that you can find traces of data science in those areas. Why we apply data science? You want to reduce the uncertainty and dramatically shorten the life cycle of exploration and save costs, and also increase your discovery rate. So these are the areas that you can enhance the process with the help of some of the latest technologies. Next one is moving the earth. That's where it's a pretty labor-intensive process that involves heavy equipment, lots of sensor data that's available there. Major problems there is equipment maintenance and cost of those equipment. Components are expensive, And also, most of them are being operated by humans up to this date. So operator productivity is also a main challenge in that domain. And last but not least is the mineral processing, getting the precious metal out of that earth that's been moved. Again, different traditional techniques involves, having a processing plants and PLC control systems there, called regulatory control systems as well. The role of the data science and machine learning is to add another layer of optimization on top of that traditional one and increasing the efficiency of the process, because that's also very complex, multivariate process that can dramatically change the cost of the extraction. And you can find techniques such as predictive control, fault detection, and some machine vision based technologies there. But for the purpose of my focus on this talk, I'm going to be touching on the number 2, which is the moving piece, and where I spend most of my time in the mining and heavy equipment there. And I'm going to be talking to you about 2 main themes again. Number 1, operator productivity, and I call it true productivity. And the challenge here is to look at your, different operators that either operating your loading equipment or hauling equipment, and being able to distinguish between who is actually a high efficiency and making the best use of time and the resources, and who's lagging behind, to provide that targeted training, as Kevin highlighted, to the operators, and that can have substantial amount of gains for the operations. The issue with the traditional methods is they are univariate again. Typically, when you look at a FMS solution, fleet management solution, they usually report on tons per hour moved by operator, and that's their measure for their operator scorecard, in a sense. However, that's again a univariate look of a person's behavior, which may not be fair representation of his or her work. Because in a mining environment, there's a lot of moving pieces that are outside the control of the operator. So the question is, what are the external variables that are beyond the control of the operator that can impact positively or negatively the productivity, tons moved per hour? And again, there's the list of the variables could go on and on, but major ones is payload, distance traveled, elevations, fuel consumed, type of truck they drive, because it could be very different types of truck. And if I'm lucky driver and I'm being put in a short haul cycle with a shovel operator that gives me more than the benchmark load, my tons per hour moved is going to be higher than another person who's not as lucky as me and being in a different condition or a different crew, for example. So understanding this variability can help with that targeted training. And that's where the role of the data science comes in, that using inference analysis techniques or machine learning models to understand the impact of these variables, both for hauling cycles as well as the loading cycles. And once we know that, be able to extract those biases and look at a normalized, unbiased view of the operator performance, taking into account all of those operating conditions. Application, again, targeted training for operators. And once we know that impact, you can control the controllables. And that's the key. Once you know about how much haul road distance or how much payload, how much elevation is going to impact the productivity, you can forecast better, you can improve those variables to your advantage. And obviously the benefit for the operations is increasing the production and throughput. If your operation is limited in the increased production, in some cases, you might want to park some of the trucks and reduce your cost per ton, and maintenance and tires, all the consumables as well as labor, which can again add to the reducing the all-sustaining cost. So that's the true productivity, operator productivity and application of machine learning. Next one is the predictive maintenance, which is, I would say, more challenging problem than the previous one in terms of the availability of the data. Predictive maintenance, it's becomes pretty buzzword in this industry and other industries as well. But really, the challenge we're dealing with here is you're predicting a rare but very expensive event. So rare, you don't have enough ground truth data to train your models. And if you do, they may not be good quality. It might be the collection of data. It may not suggest a sound scientific methods being built upon that. So there's a lot of challenges with that. And but one of the ways that you could look at it, and what we've looked at in the past, was looking at some of the information we get from the trucks to start tackling that without a look at the historical, let's say, work order data. Look at the occurrence or duration of major fault events. That can they be an indicator for a catastrophic failure in the future? And this prediction could have different time horizons based on your business objective. It could be more tactical, short term. You're looking at a week or two time frame that you want to predict certain events. Could be even severe faults within that time frame, or it could be longer major component failure, transmission, engines. These are again expensive components. First of all, that you may not have them available, and takes time, and they could range from typically from $500,000 to $1.5 million a component. And the other challenge for the site is when and where they break can, in addition to the equipment and component cost, the maintenance cost, they can impact the operations. Let's say they break in the middle of the haul road or in an intersection, they may put pause on the entire operations for a few hours. Or if not, you may need to decommission a second truck to tow the down truck to the shop, so you lose another truck for a couple of hours and a major one for maybe a week's matter. So again, that's pretty challenging situation for a site. Data science approach to that is, let's start from some basic correlation and pattern recognition. Let's take a look at the correlation between the fault codes and events that are happening and leading to a failure or leading to a major event. Data comes from the telematics, from the FMS system, and the IoT devices, additional devices such as Cascadia offers, and could be weather station data, other multiple different sensor data that put some examples here to take a look. For example, on the bottom right image that you see, let me bring my teams here. All these, you see red bars and the blue purple bars that shows the red bars show all the machines that have had engine failure, and blues that they have never had an engine failure. And you can see, between 1 to 8 months.
2 minutes left.
Okay, good. No, I think this is my last. Between 1 to 8 months prior to a catastrophic event, a number of occurrence of certain engine faults have been increasing. So they can even visually infer that. Obviously, you have to run it through the scientific methods of concluding that. But these are some of the challenges or clues that we could take a look. Or another one is one fault leading into other faults. And the other two pictures is the correlation between coolant temperature versus a fuel transfer pump outlet, or coolant temperature and engine oil temperature. that when one goes up, there's a high chance the other one goes up, and that, leading to other events. So these are, again, the areas that data science community have been active in terms of looking at, certainly to my interest as well. And again, benefit is avoid cycle interruption and reduce maintenance cost. I've also put some references at the end about some of the other techniques that are available. So if anyone interested, they can take a look. And that's it. And I open up to any questions, please.
Thanks, Payam. That was great. So I'm consolidating questions from the chat, and so we'll start with Leonardo. Is there a role for old school first principle predictions using rim pull curves, Markov chains, etc.?
In what application? Like, that's a pretty generic question, I would say.
Okay, we'll move on to the next one. We can, if there's clarification needed, we can absolutely answer in retrospect after the meeting. Okay, so the next one from Udaya. Given that the ground truth is limited for predictive maintenance, how do you handle the interpretability of ML models when predicting a rate event?
Yeah, I mean, that's a good one. I mean, we first attempt is to start straightening up your data set and start collecting those events and having a very close this collaboration with the maintenance team that you're working with, and start really building that ground truth data. I think that would be the key, because you might not have it now, but 2 years from now, you could build a clean, labeled ground truth data that you could use it for the machine learning purposes. So therefore, then the method is you reduce your error band in a sense. But there's if you don't have enough support for the model, your model is just not as solid as it can be, and that's the problem with the predictive maintenance events. So yeah.
Great. The next one, Brandon asks, have you had any success in modeling tire failures?
I personally haven't worked on that area, but certainly there's a few publications that are looking at it in terms of companies that are leading that area. I mean, Michelin is one of the leaders in this space. However, in terms of predictive models being applied to the tire pressure, temperature readings that they get, they haven't demonstrated that in their product offering, at least to my knowledge. But in the academic space, you might find some cool stuff.
Very cool. Next one, Angela asks, how many data science team members do you have at Equinox?
At Equinox, we're different, in a sense that we work very closely with the operations, and also with our team of consultants outside Equinox. We are in a very early stage of building our data science capabilities in-house, and definitely working closely with the operations to extract the talent that we currently have in the operations and build some knowledge space and lay the ground for the extended team.
Great. David asks, how much of an impact can data science have on operational costs? Fairly generic, but perhaps you could shed some light.
Value in terms of dollar value, you mean, David?
Let's just go with dollar value, sure.
Yeah. I mean, that's a good question. I think there are different pricing or cost benefit models that I've looked at in the past, which is you look at again, let's pick the operator scorecard as an example. Increasing if you reduce your cycle time based on the operator efficiency every second, how much value it's going to have in terms of tons moved. There are sort of formulas that you can put together in terms of calculate how much every seconds for that specific mine can add value, and calculate the revenue added in one direction, and the other one is cost saved, which is every hour of parking and equipment, how much is it going to save with the labor, tires, consumables, as well as the maintenance that is equivalent. So the two ways, David, that you can break it down, that you can put revenue or cost associated to each one, and then build an estimation for the benefit.
Hey, Steve, a new one came across. How are you using ML in collaboration with data from FMSs for isolation for impact projects? That was from George.
Not entirely sure about the isolation impact project. If you can elaborate on that.
He might have been borrowing from our nomenclature, Payam. I think, just explainer models, explaining behavior and performance.
Could you repeat the question, Kevin, please?
How are you using machine learning in collaboration with data from fleet management systems for isolation for impact, or for explaining different cycle properties in terms of their impact on haulage?
I'm not sure if I understand the question properly, but the data behind the operator scorecard is a few things, like FMS for sure, because you have every event labeled in terms of the time it took from each equipment and loading, elevation, all that. It comes from an FMS. And then you collaboration with other data sources such as weather. Again, that's another thing that we looked at, because we're looking at some northern Alberta locations that the weather was pretty severe in terms of the winters and summers, pretty diverse range change between the seasons. And yeah, definitely, I'm always, as a data scientist, you always want more data. You're having more data, you can probably filter through the noise and have a better prediction. So, and in conjunction with the ECM data as well, that's where you get all the abusive events and the engine events that can also, or the fuel consumption as well.
For our part, the one critical piece of information that an FMS provides us that's not sensor data, not available by talking to the engine, is who was on the truck when. And that for, I'm not sure about for Equinox, but for us, knowing who was on the truck when, which comes from the FMS, in a way that we can't get in the same way that you would get a temperature or pressure or vibration. So another question, this is from me, Payam, and I know this is something that I think you and I both face, is that there seems to be a lot of support for machine learning initiatives in corporate head offices around the world, in places like Vancouver and places like Perth, and in other kind of glass towers, and then often convincing the people who have to put the intelligence and the insights to work can be quite challenging. So this is a problem I faced at many sites, but is Equinox facing this similar challenge, and how do you kind of convey the importance or the utility of machine learning to people who may be in an older industry that isn't quite as data forward?
Certainly, I share the challenge with you, Kevin. It's been the communication to the or translating these advanced technologies that have been existing in other industries. Predictive maintenance is pretty advanced in think about aerospace industry and industries similar to that. But in mining, definitely it takes more time and more mind shifting towards that. But I think, we're in the right path with providing more education and collaboration really with the operations and people who are in the forefront, and hearing their pain points. I think it takes longer time than other industries, but I think we're definitely in the right path.
Another question for you, Payam. This is from Ephraim. Does your team have a plan to use ML to improve mill performance using geometallurgical models? And thanks to Steve Sullivan, who also actually posted a link responding. But go ahead, Payam, please answer.
Yeah, the answer is no. I mean, again, as I mentioned, most of my focus has been in my mining space, the mining operations space, not the mineral exploration and processing space yet. But that doesn't mean it's not going to change. So we're putting our focus right now on the mining operations. But as I put also some references, there are really some really cool studies and work out there that are using latest technology, even comparing different machine learning and deep learning techniques in mineral exploration, and how it can significantly reduce the cycle time of the exploration. It's fascinating to me, but it hasn't been my focus yet.
Okay. I think we've got time for one more question. There's two in the chat, so Payam, I'll give you both and let you choose the one you want to answer more. One of them was, given that you've got mines in 4 different countries that are geographically diverse, are you building ML models that consolidate the data from all of those operations, or are you treating them more site specifically? That was from Jessica. And then from Udaya, what is one of the most challenging projects you've handled? And I think with that, we'll have to move on to the next speaker after your response.
For sure. I'll take the first one. There's definitely a benefits to both approach. This famous notion of local versus global approach, and there's benefit in both. That when you think about a trend, a time series data. I use a simple example. That's from the when you look at 30 years of histories of, let's say, stock market, you see some global trends that can help you forecast or be more optimized for the future looking, that you can get from that larger granularity, again, being all sites in our example. Or when you look deeper on a daily frequency or weekly frequency, there's other nuances that you can leverage. So it's not one or the other, in my view. It's leveraging both the characteristics for different business objectives, which I think is the most important one. With that, I think.
Well, thank you so much, Pam. That's great.